Hey guys, what's going on? In this video, we're going to be creating a smart contract that executes a flash loan using the Aave DeFi protocol. Flash loans are a relatively new concept that have no real equivalent in the traditional financial world. They allow you to borrow as many tokens as you want without collateral, provided that you pay it back as well as a small fee, all within the same transaction. Some common use cases of flash loans include refinancing existing loans at lower rates and performing arbitrage. Arbitrage is an investment strategy where you find a token on one exchange trading at a discount relative to another exchange. You buy low and sell high in order to capitalize on the opportunity and make a profit. So with flash loan arbitrage, you can basically borrow funds with no collateral in order to buy and sell tokens on different exchanges, pay the loan back, and walk away with a nice profit. If you don't have enough funds to pay back the loan, the entire transaction gets reverted, and so there's little to no risk of losing money. In this video, we'll go through the entire process of building a smart contract that can execute flash loans for this and other use cases. So if that sounds good, stick around and let's get into it. So if you haven't heard of Aave, they're a DeFi lending protocol which offers a bunch of different services. First of all, they custody ERC20 tokens and hold them in liquidity pools in order to make them available for borrowing. Anyone can become a liquidity provider by depositing their tokens into liquidity pools and earning a profit. Then there's the Aave token, which is used for governance of the protocol. You can stake this token and earn profits on your staked tokens for helping secure the protocol. And finally, there are flash loans. So I definitely encourage you guys to explore Aave and learn about all the cool things that you can do with this protocol. Now for this tutorial, we'll be working on the Ethereum Goerli testnet, and we'll need some tokens for testing the flash loan contract. So what you can do is go over to the Aave faucet and load up on some DAI token and USDC. So I will provide the link to this faucet in the video description, but basically you'll go to this page, you'll connect your wallet, and then simply click on the faucet button to withdraw some DAI and some USDC. And they're pretty generous with the amount of tokens that they send through the faucet, so one tranche of each token should be more than enough for this tutorial. Alright, so if we take a quick look at the flash loan documentation from Aave, we can start to get an idea of what requirements there are for our smart contract to have in order to both receive and request a loan from Aave. So if you scroll about halfway down on this page, you'll see that there's a requirement that we need to implement the Aave Flash Loan simple receiver interface, in particular the executeOperation function. So the executeOperation function, this is a function that's going to be invoked in our smart contract by Aave after they've sent us the loan funds. And what this function does, it's basically going to execute any custom logic that we've coded into the smart contract, for example, to execute the arbitrage operation. After that, we're going to have to invoke the approve function on the token that we've borrowed in order to give Aave permission to pull back the borrowed funds as well as the fee. So that's a key point to remember there, that we don't have to actually send the borrowed funds back to Aave. We just have to give them permission to pull those funds back, which they will do after this function returns. All right, so to put all this into perspective, let's take a quick look at the high-level architecture of the whole flow before we start coding. Okay, so this diagram illustrates the high-level flow of the flash loan. So on the left we have our flash loan contract, which we're going to be working on in this tutorial, and on the right-hand side we have the Aave v3 protocol. So the first thing that's going to happen is we're going to invoke the flash loan simple function in the Aave pool contract, passing in the token that we want to borrow and the amount. Now you'll notice this is flash loan simple. There's also a flash loan function. And you'd use flash loan if you want to borrow several assets at a time, some of token A, B, and C. For this tutorial, we're just using the flash loan simple to borrow one type of token, just to keep things simple. But other options are available. So at that point, the pool contract will run some checks and then send the borrowed funds back to our flash loan contract. At that point, the executeOperation function, which we've defined, will be invoked. And here's where we'll run any custom logic that we want to do. For example, the arbitrage operation. So we may do some token swaps, some buying and selling via other exchanges such as Uniswap, SushiSwap, or other decentralized exchanges. After that's completed, we will call the approve function on the borrowed ERC20 token for the amount borrowed plus the fee. in order to allow Aave to pull back those funds. And then at the conclusion of all of these operations, Aave will indeed pull back those borrowed funds plus the fee automatically back into the pool. So hopefully that gives you a high-level bird's eye view of what we're going to be building here and sort of the entire process. All right, guys, so now for the fun part, let's go ahead and start coding our contract. So I've created a folder called Flash Loan Tutorial, call yours whatever you like. I'm using Visual Studio Code, and I'll be using the hard hat framework for sort of scaffolding my project and deploying my contract. All right, so the first thing I'm going to do, I'm inside this folder, I'm going to open up the terminal, and I'm just going to go ahead and create a new hard hat project. All right, and I can do that by typing in npx hard hat. Okay, I'm going to choose create a JavaScript project. I'm going to say yes for the git ignore. Okay, and once that project is scaffolded, you'll notice that there's a little line here that says you'll need to install these dependencies in order to run the sample project. So you'll need to go ahead and install those. And you might see more than what I'm showing right here because I think I've got some of these installed already. But I'm going to go ahead and add the full list of dependencies in the description of the video. So go ahead and install those. All right, the next step is to install the Aave packages. So I'm going to run npm I at Aave / core-v3, and I'm also going to include the .env package, so we can read our JSON RPC and as well as our secret from our .env file for contract deployment. So go ahead and run those. All right, so once those packages are installed, the next step is to set up your .env file. So just create a file called .env in the root of your project, and you want to populate your, we'll create two entries, one private key. This is going to hold the private key of your wallet, and one for your Infura Goerli endpoint or whatever provider you're using to connect to the blockchain. So go ahead and populate those, and then let's update our hard hat config file. All right, so the first thing I'm going to do is require the .env package so that we can use it to pull in those variables. So I'll say require .env, then call config. Okay, and then I'll go into our exports, and right underneath Solidity, I'll create a networks object. And underneath that, I'll create entry for Goerli. And then I'll create two properties, URL and accounts URL. So now we can access the variable that we set up in .env. Infura Goerli endpoint, or whatever you called yours. And the next one's going to be accounts. And this is going to be an array of one entry containing your private key. All right, and once you've done that, go ahead and save. Okay, so next up, let's go ahead and expand the contracts folder. And we see there's a sample contract there, so let's go ahead and rename this. Oops, not the folder, the file. All right, I'm just going to call this Flash Loan. All right, so go ahead and open up that file, and then let's go ahead and delete everything inside that file. I'm going to add my license identifier, and then underneath that, let's go ahead and start with the Pragma Solidity version. And I'm going to use 0.8.10 just because that is the version that a lot of the Aave contracts that we'll be using also use. All right, next we add our imports, and since these are a bit long to type out, I'm just going to go ahead and paste these in here, and you guys can copy and paste this also from the video description or from the repository as well, and then we'll sort of go over each one line by line and explain what they mean or what we're going to use them for. Okay, so starting from the first import, Flash Loan Simple Receiver, if we remember from the documentation, it said that we need to implement this interface in order for our smart contract to be a receiver of a loan, of a Flash loan. Okay, so this is going to contain that executeOperation function that we talked about, as well as two getter functions, an address provider and a pool. Okay, and this is going to return basically a provider that is a layer of abstraction away from the pool address. Okay, and we have a base contract that we can use that does some of this implementation for us, so that the only thing we need to do is inherit from this contract and then pass in the address provider address for the network, the test network that we're on. Okay, and the rest is sort of taken care of for us here. And then the only thing left for us to do is to implement that execute operation function in our code. And finally, the last import is our good old ERC20, and we need this in order to call the approve function on the token that we're borrowing. All right, so let's continue with coding. I'm going to define the contract, and we'll say Flash Loan. And now remember, we're going to inherit from Flash Loan simple receiver base. There it is. All right, I'm going to set up an owner. We want to be able to withdraw funds from this contract because we'll be left with a profit, so we definitely want to be able to implement a withdrawal function and give access to the owner for that. But for now, we'll define our constructor. Now this is going to take an address of the provider, and I'll show you how to get that in a minute. So we'll pass in that address, which we can get from the Aave documentation. But then we're going to call the constructor of Flash Loan simple receiver base next. Flash Loan simple receiver base. Okay, and we're going to pass in the address to instantiate an instance of the PoolAddressProvider interface. So basically we need to grab this and pass in the address provider. Okay, so since the provider address is a constructor parameter, we actually need to pass that in our deployment script. So let's go ahead and set that up right now. Okay, so there's an example file here. Let's just rename that. And I'm going to call that deploy Flash Loan. All right, and I'm going to get rid of all these comments up here. And then I'm just going to get rid of everything in the main function. All right, so first I'm going to grab an instance of a contract factory. So I'll say Flash Loan equals await HRE ethers get contract factory, and we need to pass in our contract name here. So Flash Loan. Okay, then I'll say Flash Loan lowercase instance of our contract, and we'll say await Flash Loan dot deploy. All right, and here's where we'll pass in the provider address. But first, let's just go ahead and finish this up. So I'll say await Flash Loan dot deployed. All right, so we know that we've deployed the contract here, so we can go ahead and console log the address. And we'll say Flash Loan contract deployed. Yeah. Flash Loan.address. All right, so that should output our new address, or the address of our newly deployed contract. Now let's figure out where we can grab this value here. And if we go back out to Aave, there's a page called V3 Testnet Addresses. And I'll provide this the link to this page in the description of the video. But what we're looking for is PoolAddressProvider right here. So we want to go ahead and grab this value, copy that, bring that back into our script, and just paste that right here. So now this value of the address provider will be passed into our Flash Loan constructor. All right, go ahead and save that. That's a lot of setup, but we're pretty much done. One other thing that we're going to want to do is go back to the hard hat config if you still have that open. and just update the Solidity compiler version to 8.10 so that matches what we have in our smart contract. Okay, so back over in the Flash Loan smart contract, I want to set the owner to the message.sender in our constructor. So I'll cast that to payable and do message.sender. Save that. Okay, so the next thing we need to do is to write the executeOperation function. And if you remember, that was referenced in the Aave Flash Loan simple receiver interface. So we could take a look at that file to see what this should look like, at least take a look at the signature. So as you can see, there are a bunch of different parameters that are going to be passed in. I'm just going to copy this and bring it over into my Solidity contract and just paste that right here. All right, and since this is an interface, there's no implementation, so we could just add that with a couple of curly braces right there. The other thing we need to do is to mark this as an override. Since we've copied this function from the contract that we're inheriting, we now need to mark it as an override since we have a function with the same signature in our contract, if that makes sense. All right, so inside the function body here, first of all, we can add any logic that we want. So at this point, we have the funds. Let me just mark that here. So if we've gotten to this point, we actually have the loan funds in hand, and we can add any custom logic that we want here. So on the first pass, we're not going to add any custom logic. We're just going to do a pass-through, just make sure the Flash Loan works. And then we're going to add some custom logic here to do like an arbitrage, a mock arbitrage. So the next thing we need to do is, all right, so as you can see, there are a bunch of different parameters here. Asset, this is the token that we're borrowing. Amount, the amount we're borrowing, obviously. Premium, this is the loan fee. Initiator, that is, it's like the entity that triggered the borrowing in the first place, which is irrelevant in our case. And then params, the byte encoded params passed when initiating the Flash Loan. So the last two we don't need to worry about. We're not using those. So what we need to do is set up the amount owed. So I'm going to say uint 256 because this is the amount that we need to approve for the pool contract to take back. So I'll say amount owed. And this is simply going to be the amount from the parameters above plus premium. Okay, and then we can use our ERC20 interface to pass in the asset and call the approve function. And so this takes an address. So we'll say the address of the pool contract, and we'll say amount owed, which we've just defined above. And then finally, we need to return true at the end. All right, so you may be wondering where this pool variable is coming from. And if you look in the Flash Loan simple receiver base, you can see it's being set up right here in the constructor, an instance of the iPool interface, which is being inherited right here. Okay, so that gives us access to our pool, and we'll use this later again to call the function to initiate the Flash Loan in the first place. All right, and you can ignore this right now. We're not using these two parameters. So go ahead and save. All right, so the next thing we need to do is write a function that's actually going to kick off the entire process and request the loan. So I'm going to come down here and I'm going to create a new function. And let's say request Flash Loan. Okay, now this is going to wrap the actual function call to the pool contract, but we need to do some setup first. So I'll make this a public function. Okay, so that's the skeleton of this function. And if we want to see what this looks like, let's see, this is in the pool interface, I believe. Let's come down here a bit. All right, and what we're looking for is Flash Loan simple, if you remember from the docs. There it is. Receiver address asset amount params referral code. All right, so let's go ahead and grab this come back into our code. And I'm just going to paste this down here. Okay, and so I just need to know which parameters we need to pass in. So let's go right down a couple of lines below the function definition. And I'm going to use the pool variable again, pool.flash loan simple. Okay, and then we're going to pass in these. So I'm going to cut that, paste that in here, get rid of the types, since these are just parameters now. Okay, and get rid of this junk here. Okay, so the next thing we need to do is to define these parameters here. So we'll start with receiver address. And this is going to be set to the address of the current contract. So I'll say address this. Okay. Now the next two, asset and amount, I want to pass those into this function. So we set them as we call this function, right? So let's say address token. That way we can reuse this for different token requests and different amounts. This is going to be underscore amount. All right, and then we'll just set those down here. Address asset equals underscore token. And uint 256 amount equals underscore amount from the parameters. All right, so the last two params and referral code, we're just going to provide default values. So if you forget what the types were of those, you can always reference the pool interface, bytes call data, and uint 16. Okay, so bytes, memory params, and let's just use an empty string here. And referral code, we'll just set that to 0. uint 16, referral code equals 0. All right, and go ahead and save that. All right, so that completes our request flash loan function. There are a couple of more, just 2 or 3 more utility functions that I want to write that's going to help us for testing, and then we'll get to testing this contract. So the first one is going to be a get balance function. So I'm going to say function get balance, and we'll use this at the very end after our flash loan is completed, just to see what the balance of our contract is. Get balance. This will be even more useful when we do the version with the arbitrage, so that we can see any profit that's left over in the contract. All right, so this is going to take a token address, so we can look up the balance of any token. External view returns uint 256, because it's going to return a value of the balance. Okay, and in here we'll make use of our IERC20 interface. So we'll say return IERC20, instantiate with the token address that we're passing into this function. And then we'll just call balance of on that. Balance of and address of this contract. All right, so that'll give us our balance, this contract's balance of any token that we specify. All right, next we need a withdrawal function because we'll want a way to withdraw our profits after the flash loan is done. So I'll do a simple withdrawal function. I'll say withdraw. Let's make it so that we can withdraw specific tokens. Token address. So say we do an arbitrage with a USDC, then we can specify that we want to withdraw all the USDC from this contract. So again, I'll say external. All right, we're going to add a only owner modifier to this in just a second. But for now, I'll say ERC20 token equals IERC20 and pass in that token address. Oops, this should be 20, IERC20. And then we'll initiate our transfer on this token object. So I'll say token.transfer, and this takes a to and amount, okay? So we'll say message sender, which is going to be the owner of the contract. And we'll say token balance of address this. So in other words, all the holdings of this contract for this particular token. All right, and the last thing, we definitely want to make sure that this is gated to only the owner. So I'll add that, even though we don't have it yet. We'll define that as the last thing we do here. So I'll add a modifier called only owner. And we'll add our require statement. Require message.sender equals owner. And if it's not, we'll use our common message that we've used in many other contracts before, which is only the contract owner can call this function. Oops. All right. I'll fix all my spelling mistakes here. Okay, and don't forget this funny bit of syntax, which is just underscore and semicolon is a placeholder for the rest of the function that this is being applied to. All right, and finally, let's just add a receive function. Receive, just in case we want this contract to be able to receive, Ether for any reason. Payable. Go ahead and save that. Receive external payable. Oh, don't forget the curly braces at the end, and go ahead and save that. Oh, and this should not have a semicolon. So there we go. I think we're looking good now. All right, so we are ready to deploy this contract and then do some testing. All right, so let's go ahead and attempt a deployment to testnet. I'm going to open up the terminal, and I'm going to paste in my deployment script. So this is, again, we're targeting the Goerli network, and this is targeting our script that we wrote a little bit earlier. So let's go ahead and run this. And this will let us know if we have any compilation errors or something wrong with our deploy script. If all is well, it will deploy the contract. All right, and that first attempt failed because I've got a typo in my script. So let's fix that really quick. Where is that? Flash Loan. All right, I'm going to fix that to Flash Loan, and just making sure I didn't misspell it anywhere else. I think it was just that one spot. Yep. All right, let's run that again. All right, and looks like second time was a charm. So here's my deployed contract's address. I'm going to go ahead and save that to my notes. Flash Loan deployed. So that's our most recent deployment. And all right, so I've went ahead and opened up a Remix editor window in the browser, and we're going to go ahead and use Remix to test our deployed contract. So I'm going to drill into contracts here and reuse one of their sample contracts. So I'll take this number one storage one and rename it to Flash Loan. Save that. And I'm just going to delete all of the code in this file. Okay. So I'm going to go back to Visual Code. I'm going to Control A to grab all of that code, and I'm just going to paste it right here into Remix. Oops, that's the wrong file. I'm looking for our Solidity contract. There we go. Not our deployment script. Okay, much better. All right, now the only problem is that these references to my node modules folder aren't going to work in Remix. So I'm going to go ahead and copy and paste the links to the direct GitHub location of these contracts. And this is kind of a pain, but I'm sure there's an easier way to do this. But for now, I'm just going to copy those in here. Okay, so these are going to work from within Remix, and then save that file. Go ahead and open this tab here that's got the Solidity logo, and let's compile. Yep, there we go. That's updated now. And that's fine. Those are just those two warnings. So let's go down to our deployment tab, and we just need to grab our deployed contract's address and paste that in there. I've got way too many notes here. All right, where is it? There we go. And I'll expand this a little bit so you can see it better. But basically, we are connecting to a contract that's already deployed. So we just need to provide an address here. We don't need to provide the constructor parameters since we've already done that. And here I'm going to select injected provider, MetaMask. And all I need to do is come down here and hit the @address button. And here we go. Here's our interface for our contract. Okay, so basically what's going to happen here, we are going to run this request flash loan function right here. All right, so that's going to request, we're going to do let's start off with 1 USDC. So we're going to request 1 USDC from Aave. It's going to send the funds to us. We don't have any custom logic. All right, so this first pass is going to be a straight pass through. We're going to receive the funds, approve the payback, and then pay them back right away. And so there is a small fee, so I will need to send a little bit of USDC to the contract before we run this test. All right, so let's send some USDC to our contract. And I'm just going to send 1 USDC, even though that's way overkill, because I think the fee for this, we're going to borrow 1 USDC, right? And the fee is going to be 0.0005. So we definitely have more than enough. And that'll take a few seconds to settle, and then we'll check the balance right here. So in the meantime, I will grab the USDC Aave version token contract address. And we'll wait for that to finish. Once that's included in the blockchain, then we can check our contract balance. In fact, I can check it now, and it'll be 0. And let's check again. Oh, there it is. 1 USDC. Okay. All right, next step is going to be to actually run the flash loan. So the parameters are the token that we want to borrow and the amount. All right, so I've got this all set up already, and we're going to request 1 USDC. Now remember, USDC has 6 decimal places, unlike a lot of tokens that have 18. So that's why this is 1 million, which represents 1 USDC. All right, so let's go back to Remix. All right, here's our request flash loan function. So we'll enter that in, and hopefully this will work. That's a good sign if MetaMask's opening. If it was going to revert, it would let us know right away. Okay, it's going to ask us to sign the transaction. And we are off to the races. All right, and we can actually verify this on Etherscan, although it's still pending right now, but let's go ahead and open that up. And we can tell that this is still pending. Here's my wallet address. And what was our contract address again? E8. All right. Yep, and that's this one right here. So we should see that that 1 USDC followed by the fee, which is going to be 0.005. Yep, there we go. So yeah, that our flash loan was successful. Here is, let's see if we can follow the trail here. This is from the pool to the contract, from the contract to the pool. $1 and paid back $1, 0.0005. Awesome. So good to see that working. That's pretty much the most straightforward example of a flash loan, a total pass-through where we request some funds and pay it back with the fee right away without any custom logic. So as our next test, let's add some custom logic and let's do a proof of concept of how we could actually send the funds out to another contract after receiving the loan, do something with them, receive them back into the contract, pay off the loan, and hopefully walk away with some kind of profit. All right, so in order to simulate an arbitrage opportunity that we can consistently repro for the purposes of this video, I've created a new smart contract called Dex.sol. And this simulates a decentralized exchange, a simplified decentralized exchange. So this exchange works with two tokens, DAI token and USDC. And the way it works is first the user would basically approve a deposit for the token that they want to work with. They would first deposit, let's say USDC. So this contract can custody different ERC20 tokens on the user's behalf, which they can then use to trade, buy and sell whichever of the two tokens that they want to. So we're going to initiate this operation from within our executeOperation function from our Flash Loan smart contract. Okay, so the first thing we're going to do is deposit USDC. Okay, so this contract will custody the amount of USDC that we deposit. Then we're going to buy some DAI token, deposit that into the DAI holdings area, and then sell the DAI token for a profit. Now, how do we make a profit here? Well, if you notice that in the calculation of exchange rates, there are two different rates being used, Dex.A rate and Dex.B rate. Okay, so if we scroll up here and take a look at where those are defined, we can see that Dex.A rate is 90, okay, meaning that I can buy DAI token for the price of 90 cents on the USDC. And the B rate, which is being used in the sell function, is 100, which represents a 1-to-1 value between DAI token and USDC. So you can see where the arbitrage opportunity is here. Buy DAI at 90 cents on the USDC and sell for 1 USDC. Okay, so this is what we'll be doing in the next test. Okay, so in order for our Flash Loan to interact with the Dex contract, we have to make some changes, right? And so what I've done is I've created a new contract. I've basically copied the Flash Loan contract and then added the additional interactions with the Dex contract. So I think this time, instead of going line by line, it kind of makes more sense for me to show you guys the changes I've made. Since you're already comfortable with putting together the Flash Loan, since we've done that line by line, this time I think we'll save some typing and I'll just sort of step through each new addition that I've made. Okay, so first, we need to create an interface of the Dex contract in order for our Flash Loan contract to talk to the Dex contract. So that's what I've done here. We have an interface and I've listed out the function signatures for the functions that we're going to be using. Okay. Next, we need to grab a reference to the addresses of the tokens that we'll be using. So DAI and USDC in this case. And again, these can be found on the Aave website. These are the Aave specific versions of these tokens, which need to be used for testing. So that's a really important point. I got stuck up on this for a while, couldn't figure out why things weren't working with the regular link token, which I was using initially. Anyway, so here we're instantiating new instances of the tokens as well as the Dex contract so that we can call methods on it throughout this contract. And we're doing that right here in the constructor. And then here's where it starts to get interesting in the execute operation. If you remember in our original Flash Loan, we just had this part stubbed out, right? We had no custom logic. So now in this new version of the contract, we're adding the custom logic to do the interactions with the Dex contract that I just described. So we're going to be requesting an initial loan from Aave of 1,000 USDC. Okay, so at this point, we have those funds. Now we're going to deposit those funds into the Dex contract. We're going to buy some DAI token at that discounted rate of 90%. We're going to deposit those DAI tokens back into the Dex contract. And then finally, we're going to sell those DAI. And so at this point, the Dex contract will send us back USDC and we'll end up with more than we started with, right? So we'll have plenty of tokens to pay back the loan and we should walk away with a profit of about $110, give or take. All right, and I believe the rest of the contract is exactly the same as the first one. Oh, we have some methods down here for the USDC and DAI tokens. There is one additional step before we request our loan. we're going to need to approve some amount of USDC and DAI token so that the DEX contract can pull those amounts for our deposit. Okay, and unfortunately we can't do that all within one step because those approvals need to be available on the blockchain before any of these functions run. Okay, so that does add one extra step to the process. But the good news is we don't need to hold those funds in order to approve them. So we can still have a balance of 0 USDC and put through an approval of 10,000 or 1,000 or whatever we intend to borrow. So net result is that we can still borrow money with the Flash loan with 0 down. And as far as the rest of the contract, it's exactly the same as our original Flash loan. All right, so let's test out our arbitrage example. And guys, just as a reminder, all of this code will be available in the GitHub repo for this project, for this video, which I will definitely link in the description of this video. So if you guys want to follow along and run this arbitrage example, here's what you would do. You would download the repo, so you have the code here. You would go ahead and deploy Flash Loan Arbitrage as well as Dex via Hardhat. Deploy that to the blockchain and go ahead and save those public addresses that you'll get back from there. And from there, you'll want to copy and paste the code into Remix, as we've done before with the previous examples, compile that code here in the Compile tab, and then deploy them using the @address with the public address of the deployed contract. All right, so you get sort of the interface down here of each contract. Now, as far as the steps for running the specific arbitrage example, there are a couple of extra things we need to do. So first, we need to fund the DEX contract with some tokens, some DAI and USDC tokens, just so that there's some liquidity so that the contract is able to handle these buy and sell operations. Okay. So what I've done is through my MetaMask wallet, I have, let's see, I've added 1,500 DAI and 1,500 USDC. So we can actually verify. Let's check USDC first. All right, so we're in the DEX contract and we can use the get balance, which takes a token address. So this should have 1,500. Yep, that looks good. And let's also verify the DAI token balance. So make sure you delete that completely. And there we go. And again, the difference in decimals is simply because the DAI token takes 18 or has 18 decimal places, whereas USDC takes or has 6 decimal places. So that actually caused me to have to do some math here for the exchange rate. Where is it? That's what this times 10 to the 12 is. That's the conversion from 18 to 6 decimal places. And here we're dividing by 10 to the 12. All right, so the next step is, once everything is deployed, is to go ahead and do the approval. So we need to approve the transfer of DAI token and USDC for the DEX. And the reason for that is because, like I said, the first step is going to be to deposit USDC. And if you look at the deposit code here, it's using transfer from. And if you look at the ERC20 documentation, basically, in order to perform a transfer from, you have to have pre-approval. And you see the line right above that is checking the allowance of this token. Okay, and so that's why we need to do this additional step here. So I'm going to go down to my notes and look at so I'm approving, let's see, how many is this? 1, 2, 3, 4, 5, 6. I'm approving 1,000 USDC because that's the amount I'll be depositing. That's the amount I'll be receiving from the Flash loan. So I want to go up to, where is it? Oh, this is on the Flash Loan Arbitrage contract. So you'll be able to find, where is it? Approve USDC, this one right here. Okay, that should prompt, yeah, MetaMask to open and ask me to sign this transaction. All right, and I need to do the same for DAI. So I'm going to approve 1,200 DAI tokens. All right, and we'll give those a couple of seconds to a few minutes to settle on the blockchain. Those transactions need to be recorded on the blockchain before we can run the test. And then we can check those approvals via the allowance functions right here. All right, so now we're ready to run the test and request our Flash Loan. Now remember, the request Flash Loan function takes a token address and a token amount. So I've got that prepared right here, and we're going to be requesting 1,000 USDC. So let me go back to Remix and enter that in here, and I'll go ahead and click on Request Flash Loan. It's always a good sign when MetaMask opens up, because again, we'd see any errors right away. If the function was going to revert, we would typically see that pretty immediately. So I'm going to go ahead and confirm this request, and we will let this run. And I can already open it up on Etherscan, so we can wait for this transaction to settle. All right, and it looks like it's complete. I see a success message here, and let's take a look at what's happening. All right, so the first transaction is 1,000 USDC into our smart contract. The second one is transfer of 1,000 USDC from smart contract to the Dex contract. Then we have a purchase of DAI. This should be the deposit of DAI. And then we have a purchase of USDC with that full amount of DAI. And then finally, we see the payback of the loan plus the 0.0005 fee. So everything looks good there. I see all the transactions that I was expecting. And the final confirmation is going to be to check the balance of our Flash Loan smart contract, which I can do over here back in Remix. And let's see. So I'm going to check the balance of USDC. So I just need to grab the USDC address. Come back here, and what should it be after all said and done? I think about 110 or so. Let's see. Yep, there we go. So if you take away 6 decimal places, we end up with a net profit of 110.6111 USDC. So our Flash Loan was successful. And again, just to recap all of the order of operations here. First, we requested 1,000 USDC. Okay, then we deposited 1,000 USDC, that full amount, into our Dex account. Okay, then we used those funds to buy DAI at a discounted rate of 90% on the USDC. Then we deposited that DAI into our Dex contract. Then we used that full balance, DAI balance of, to sell it back for USDC, which was then sent back to our contract. Okay, we then approved the amount of the loan plus the fee, and our Aave pool pulled those funds back, the original loan amount plus the fee, and we ended up with our net profit of 110 USDC. Great, so yeah, awesome to see this working, and hopefully you guys got the same result, and everything seems to be working as expected. So there you go, Flash Loan with Arbitrage. All right, guys, that'll do it for this video. Thanks for watching. Please give it a thumbs up and subscribe if you haven't already. I'm trying to grow this channel, so I appreciate it. That helps me out a lot. I'll be doing some more DeFi-related videos in the future, as well as some more beginner-related videos. I'm trying to, put out a healthy mix of kind of everything. So yeah, again, appreciate it, and I will catch you guys in the next one. Peace out.